Scientists' plans: how humans can live on Mars? Humans will absolutely be on Mars in the future, NASA chief scientist Jim Green says. NASA wants to send humans to the red planet by 2030, and SpaceX wants to get there even sooner, with plans to have people there by 2024. As the NASA Artemis I mission paves the way for exploration of Mars, the question remains, can humans live on Mars? The answer seems to be it's possible. Many scientists consider Mars and Earth twins because of the similarities between the planets. But they aren't entirely alike. The atmosphere of Mars is mostly carbon dioxide, the surface of the planet is too cold to sustain human life, and the planet's gravity is a mere 38% of Earth's. Plus, the atmosphere on Mars is equivalent to about 1% of the Earth's atmosphere at sea level. That makes getting to the surface tricky. How will NASA get there? How can we hope to survive against such odds? Some challenges would need to be overcome before humans could start calling Mars home. We need to consider many things: the differences between Earth and Mars, how long is a day on Mars, what are our basic survival needs, and more. Differences between Earth and Mars. Mars is more Earth-like than any other planet in the solar system, making it an attractive second option for the human race. There's also a natural beauty on the planet, a Grand Canyon that measures nearly the entire width of the US and a volcano the size of Arizona. There are some similarities between Earth and Mars, such as the fact that they both rotate around the Sun and have a similar axis tilt. However, there are important differences between the two planets, such as the Earth's atmosphere is composed of nitrogen and oxygen. Mars, on the other hand, is carbon dioxide-based. While both planets have ice caps, the ice contains different elements. On Earth, ice contains just water. On Mars, ice is a mixture of water and carbon dioxide. Mars' surface is rock and dust, while Earth's surface is 70% water. Two satellites orbit Mars, namely, Phobos and Deimos. The Moon is the only satellite to orbit the Earth. There are some climates on Earth that experience extreme temperature shifts between seasons. However, that does not compare to what humans would encounter on Mars. According to the National Weather Service, average temperatures on Mars are -81 degrees Fahrenheit. It can get to -220 degrees in winter, while in summer, it can be a pleasant +70. The time it takes Mars to orbit the Sun is longer than it is for Earth. However, a day on Mars is about the same amount of time as it is on Earth. How long is a day on Mars? One thing that attracts scientists to the idea of humans living on Mars is that it has a similar axis tilt and orbits the Sun. However, the orbit is longer than that of Earth. So exactly how long is a day on Mars? Well, because Mars is further from the Sun, it takes the planet 687 days to orbit it. Compared to the 365 days for Earth, that makes a Mars year much longer. Even with this time discrepancy, the length of a Mars day is similar to Earth. A full day's rotation on its axis takes 24 hours and 37 minutes. Or, about 40 minutes longer. Another similarity between Earth and Mars is the presence of seasons on the red planet. However, the temperature is much more extreme due to the thin atmosphere and proximity to the Sun. Challenges of living on Mars. There are 4 primary necessities for human survival. These are water, shelter, food, and oxygen. And these are all issues that we must address as we ponder, can humans live on Mars? Water on Mars. Scientists have found water on Mars, but not in the same form it's found on Earth. There is some water on the surface and below, but because of the extreme cold on Mars, it is all ice. And not the ice like we experience on Earth. On Earth, ice is just water, but on Mars, with the high levels of CO2, ice contains water ice mixed with CO2 ice. There is also water inside of rocks, but the lack of surface water would be a challenge for humans wanting to settle on Mars. Scientists continue to learn more about Mars, which will help them find out where we could obtain water from. Shelter on Mars. Building places to live on Mars poses a challenge. Transporting construction materials to Mars could end up being way too expensive. So, scientists propose the possibility of using materials from Mars to construct homes. Homes on Mars would need to withstand radiation levels, temperature fluctuations, lack of oxygen, and other conditions on Mars. And new environments call for alternative structures. A few possibilities are that humans could live in ice igloos or below the ground surface. Also, many designers have created above-the-surface habitats that fit the necessary specifications. Food on Mars. Growing food on Mars won't look like the farms that we have on Earth. Instead, crops would need to be grown without soil, such as tank farming or aquaculture. This is where the food would be planted in nutrient-rich water and fed with artificial lights. Some scientists have discussed creating a more suitable atmosphere for growing food on Mars. That would involve adding some greenhouse gases into the Martian atmosphere to make it thicker. However, due to the enormity of that project, it's more realistic to think that humans living on Mars would rely on aquaculture. Air on Mars. Humans need oxygen to survive. And the Earth provides plenty in our atmosphere. So, one of the biggest challenges of putting people on the planet is the shortage of oxygen. The air on Mars is thinner than that on Earth. On Earth, 21% of the air is oxygen, which is what makes it the ideal place for human life. But on Mars, oxygen makes up 0.13% of the air. The majority is carbon dioxide, which is harmful to humans. NASA has been experimenting with MOXIE, an instrument that would convert CO2 to oxygen on Mars. So far, this instrument on the Mars Perseverance rover has managed to successfully create oxygen from CO2. This leads the way for bigger experiments and possibilities for air on Mars. Other challenges of living on Mars. Aside from the necessities to sustain life, there are other challenges that people would face if they were to live on Mars. For example, the temperature gets very, very cold at night, below -100 degrees Fahrenheit. Mars also has dust storms, high levels of radiation, and less gravity than Earth. So, before we can start to call the red planet home, we'll need to solve these problems. We would need to wear spacesuits all the time. Weather on Mars is extreme. The difference between Monday and Tuesday could be 170 degrees. The average temperature is well below zero. The air is also largely carbon dioxide, good for planets, bad for people. We'd have to get used to dust storms. About every 26 months, it's summer on Mars, meaning prime dust storm season. These storms, made up of fine dust that gets caught in the atmosphere, can darken daylight to a twilight stage and last months. We need to build an entire infrastructure. The first humans on Mars would need to farm and establish a food source. Scientists believe beans, asparagus and potatoes are viable crops for soil there. Homes would also need to be built. 3D printers might be able to use dust on the planet to create habitats. Scientists' plans to live on Mars. Traveling to Mars is just the first leg of the journey. When Earth and Mars are closest to each other, the trip will take a mere 260 days. Once we get there, the challenge becomes landing on the planet's surface. What type of landing system will get our astronauts and colonists safely to the surface? Habitation on Mars. NASA is already considering what kind of habitation we'll need to survive on the surface of Mars. Growth of plants. Keeping the food and medicine supplies stocked on Mars is the best way to make a habitat self-sustaining, but with a thin atmosphere and reduced sunlight, it can be difficult to get anything to grow. Artificial leaves, designed to work in harsh conditions, could offer a solution for first aid. These leaves, made of silicone rubber, can take a little bit of sunlight and turn it into enough power to fuel the necessary chemical reactions to make medicine and other compounds. It can use sunlight during the day on Mars, even though it is potentially exposed to more harmful UV rays. The channels inside the leaf are protected because your device can re-emit the energy it collects at a safer wavelength, which allows any chemical processes to take place. Terraforming. Terraforming has a connotation of humans making another planetary body, like Mars, Earth-like. But really, it's about humans changing their environment to make it more supportive of our need. When you think of astronauts on Mars, what comes to mind? Did you picture a red planet turning green with time and continued human colonization? Unfortunately, those days are far in the future. The first few trips to Mars will only include the essentials. One of NASA's first goals for its astronauts is to learn how to live on the planet. Since it differs greatly from Earth, survival is an important skill for astronauts to master. After the NASA base is well established and the astronauts learn survival basics, things get more interesting. Detoxified soil isn't the only thing astronauts will need to grow plants. They'll also need to utilize the water from Mars' ice-capped poles. The key takeaway is that the planet doesn't have to transform into Earth 2.0. Maybe one day it will, but for the time being, it just has to function for NASA scientists to live and work. 4 people will start living on Mars. As scientists and engineers continue to develop the capability to send humans to Mars in the near future, 4 humans will live the dream this summer as they begin living on Mars. However, their Martian homes will be on Earth. The 4 volunteers are part of a year-long mission to prepare humans for the exploration of the Red Planet. They will live in a habitat that will simulate conditions on Mars when humans arrive on the Red Planet in the near future. The 3D printed habitat includes private crew quarters, a kitchen, and dedicated areas for medical, recreation, fitness, work, and crop growth activities, as well as a technical work area and 2 bathrooms. The crew is scheduled to begin in June this year as the teams obtain the most accurate data during the analog mission. During the simulation, crew members will carry out different types of mission activities, including simulated spacewalks, robotic operations, habitat maintenance, personal hygiene, exercise, and crop growth, NASA said in a statement. The crew will also face environmental stressors such as resource limitations, isolation, and equipment failure in order to be as close to the situation on Mars when humans arrive. The team will be subjected to resource limitations, isolation, equipment failure, and significant workloads during their habitation. The major crew activities during the analog may consist of simulated spacewalks including virtual reality, communications, crop growth, meal preparation and consumption, exercise, hygiene activities, maintenance work, personal time, science work, and sleep, NASA has said in its mission brief. Crew members will spend time remotely operating robotic elements, which will likely be necessary for real crews on Mars to extend their exploration capabilities. They will also be responsible for controlling a helicopter-like drone and a roving robot. The American Space Agency is planning 3 such analog missions to better understand the requirements for a habitat on our next-door cosmic neighbor. While Analog Mission 1 commences this year, the second mission will be conducted in 2025 and the third mission will be followed up in 2026. It's hidden in future. Mars has captured the imagination of humans for decades. These plans are just the next step in the process of getting the Mars mission from the drawing room floor to a funded mission with a launch date. NASA isn't the only ones with their eyes on Mars. Others are already coming up with their own plans for the Red Planet. Scientists and enthusiasts have speculated on everything from nuking the planet into habitability to creating a magnetic shield around the planet to encourage it to grow its own atmosphere. Mars is hopefully just our first step into the universe. Once we've dipped our toes out into the solar system, it will be easier to expand out into the asteroid belt and beyond. Mars' low gravity provides the perfect platform for constructing and launching other deep space vehicles. After we've got that foothold, the only thing holding us back is our technology. As it is, technology is the Achilles heel of the mission now. We might have a way to get to Mars before we have a means of safe exploration. Those of us who have grown up watching the Apollo missions, space shuttles take off, and now the Falcon rockets climbing through the atmosphere likely won't see Mars colonized in our lifetimes. But that doesn't negate the wonder we all feel every time one of those rockets soars into the sky. It's not just a rocket, but a source of inspiration for generations to come, one of which will step foot on Martian soil.